Given matrix A equals to that, Roman 1, determine A squared and the inverse of matrix A, and then Roman 2, show that inverse of matrix A times A squared is equals to matrix A. Solution. A squared would be equal to 1 minus 2, 1, 1, negative 1, 1, 2, 1, 3 times 1, 2, 1, and negative 1, 1, 2, 1, 3. So when you're given a matrix to square, you don't square the elements, but you simply multiply the matrix by itself. But when you square each element, then you will not get the correct results. So we have this, so we need to multiply this. This equals to, so we normally multiply row and column. Row and column. For example, here we shall take 1 times 1, we get 1, plus negative 2 times 1, so we shall have minus 2, and then of course we have 2 times 1 times 2, we have plus 2, we have plus 2. We are through with that. Then we'll move on with the second element. It will be 1 times negative 2. We have negative 2. Then negative 2 times negative 1. We have plus 2. Then we have 1 times 1. So plus 1. We go to the last element. It will be 1 times 1. We have 1. And then we have negative 2 times 1. We have minus 2. And then we have 1 times 3. We have 3. And 9. So we are through with the first row. We go to the middle row. It will be 1 times 1. It's 1. Then negative 1 times 1. Negative 1. And then we have 1 times 2 plus 2, like that. Then we move on. 1 times negative 2, have negative 2. Then negative 1 times negative 1 plus 1. And then we have 1 times 1 plus 1. Then the last, we have 1 times 1, we have 1. Negative 1 times 1, negative 1. 1 times 3, we have 3. One. We have 3. And the last one, we have 2 times 1. We have 2. We have 2. Then we have 1 times 1. We have plus 1. 3 times 2 plus 6. Then we move on. 2 times 2. 2 times negative 2, we have negative 4. 1 times negative 1 minus 1. 3 times 1, we have plus 3. Then lastly we have 2 times 1, we have 2. 1 times 1 plus 1. 3 times 3 plus 9. Like that. So this equals to, of course, then here 1 minus 2 plus 1 minus 2 plus 2. So it's like 3 minus 2, we have 1. Then 2 minus 2 plus 2, 0 plus 1, that is 1. Then 1 minus 2 minus 1 plus 3 is plus 3. So we shall have 2, and then we have 1 minus 1 plus 2, we have 2, minus 2 plus 1 plus 1, we have 0, and then 1 minus 3 plus 3, we have 3, then 2, here we have 9, minus this minus 5 plus 2, negative 2, and then we have 12. We have 12. So this is matrix A squared. So we can write here that A squared equals 2, 1, 1, 2, 2, 3, then we have 9, negative 2, 12. So that's matrix A squared. So we have matrix A squared, so we need to move on and get the inverse of matrix A. We need to get the inverse of matrix A. Now, before we get the inverse of matrix A, we need to get the determinant of matrix A. Determinant of matrix A, so we have 1 minus 2, 1, 1 minus 1, 1, 2, 1, 3. So this equals to 1, get the determinant of A. So we shall have 1. Take 1 from this, so we have negative 1, 1, 1, 3. Then of course minus 2. We plug this and that, so we have 1, 1, 2, 3. Then of course plus this one, plug that column and this row, so we have plus 1 into, so we have 1 minus 1, then 2, 1. Okay, so this equals to 3 times negative 1, we have negative 3. So we have negative 3, 1 times 1, minus 1. Then this plus, minus, plus 2 into 3 times 1, 3, minus 2 times 1, minus 2. Then plus 1 into 1 times 1, 1, minus 2, like that. So this equals to this minus 4 plus 1 plus 2 plus 2. And here we have minus 2 minus 1, so it's 3 times 1, so plus 3. Minus 4 plus 2 plus 3, 5, so we have 1. So therefore, determinant equals to 1. Determinant equals to 1. Determinant of matrix A equals to 1. So after getting the determinant, we now get the matrix of cofactors of element A. We shall say let the matrix of cofactors be C equals to A1, A1 3, A21, A22, A23, A31, A32, A33. So this is the element of cofactors, and we shall be able to get this matrix from matrix A. So how do we get A1, the the element A11. So this element, we shall take the place sign of 1, which is positive. Then the minus of element 1, you plug this row and this column, it will be negative 1, 1, 1, and 3. So minus 1, 1, 1, 3, like that. So this equals to, of course, the place sign is positive. 3 times negative 1, we have negative 3. Then minus 1 times 1, which is 1. So this equals to plus minus 4, which equals to minus 4. A, now get this, A1, 2 equals to the, so this element, so we get the place sign of element 2 is negative, and then the minus of element 2, we plug this column and plug this row, so we have 1, 1, 2, 3. 1, 1, 2, 3. This equals to minus is the place sign. 3 times 1, we have 3. Then minus 2 times 1, we have 2. Like that. So this equals to minus into 3 minus 2, we have 1, which equals to minus, minus 1. Then this element, the place sign of element 1, positive, negative, positive, so it will be positive. Then the minus of element 1, we plug this column and plug this row, so we have 1, negative 1, 2, 1. We have 1, negative 1, then 2, 1. So this equals to plus into 1 times 1 is 1, minus, so it will be minus, minus 2. When you take 2 times negative 1, you get negative 2, so we have that. So this equals to plus into, so this is will be 1, minus and minus turns to be positive, so 1 plus 2, which is 3, so this equals to 3, is equals to 3. So we move on and get, so we are through with this. Now find A21. So this we take the place sign of this element, positive, negative, to be negative, and then the minus of this element, you plug this column and plug this row, so you have negative 2, 1, negative 2, 1, and then 1, 3, like that. So this equals to minus into 3 times negative 2, we have negative 6, then minus 1 times 1, which is 1. So this equals to negative minus 7, so it turns out to be positive 7. It turns out to be positive 7. A22, we have this element. So the place sign of this element, positive, negative, positive, it will be positive. Then the minus of this element, you plug this column and plug this row. So we have 1, 1, 2, 3. 1, 1, 2, 3. Like that. So equals to 3 times 1, which is 3, minus 2 times 1, which is 2. So this equals to 1. So that element equals to 1. Then we move on to A23. A23, we have this element. The place sign of this element, positive, negative, positive, negative. So it will be negative. So this element will plug this. It will plug this column. We plug this column and this row, so that we will make negative 1, negative 2, and then 2, 1, like that. So this equals to minus into 1 times 1, we have 1, minus, 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 minus 4. minus minus 4, so this is the same as 5. 1 plus 4, which is 5, because negative and negative will be positive. Therefore, this equals negative 5 because of the place sign. A23, no, A31, we are now the place sign of 2. Positive, negative, positive, it will be positive. And then the minus of this element, we plug this column and plug this row. So we have negative 2, then 1, negative 2, 1, then negative 1, 1, like that. So equals to plus into, so negative 1 times negative 2, we have negative 2, and then minus negative 1 times 1 is negative 1, like that. So this equals to, so this negative 2 minus minus 1 is the same as negative 2 plus 1. So negative 2 plus 1 will remain with negative 1. This is negative 1. A32, we have this element. So the place sign of this element, positive, negative, positive, negative. So it will be negative. The minus of this element, we plug this column and this row. So we have 1, 1, 1, 1. So it will be 1 minus 1, 1 times 1, then this one equals to 0. Then we have A33. So the place sign of this element is positive. And then the minus of this element, we plug that column and this row, 1, negative 2, 1, negative 2, and then 1, negative 1. So this equals to plus into negative 1 times 1, we have negative 1, then minus 1 times negative 2, we have minus 2. So negative 1 plus 2, so we have 1. So this will be 1. Now, after getting this, so we are saying that this matrix, the matrix of cofactors, we collect them. So our A11, which is negative 4, then we have negative 1, then we have 3, then A21, we have 7, we have 1, negative 5, A31, we have negative 1, 0, and then 1, like that. So this is our matrix C. The matrix of cofactors is given by that. Then from there we get the transpose of matrix C. Transpose is simply interchanging rows and columns. So here I'll have negative 4, then 7, negative 1, then I have negative 1, 0, then I have 3, negative 5, then 1. So when you transpose this matrix, you get this matrix. So once you transpose this matrix, now this one equals to adjoint of matrix A. This equals to adjoint of matrix A. And we know that when you take the inverse of A equals to 1 over determinant times adjoint matrix. You will be able to get the inverse of a given matrix. Therefore, now that we have the adjoint and then we have the determinant, therefore we shall say inverse of A will be equal to, the determinant was 1, so it will be 1 out of 1 into the adjoint, which is now this one, negative 4, 7, negative 1, negative 1, 1, 0, 3, negative 5, 1, which equals to negative 4, 7, negative 1, negative 1, 1, 0, 3, negative 5, 1. So the inverse matrix equals to negative 4, 7, negative 1, negative 1, 1, 0, 3, negative 5, 1. Like that. So from here, the one that's now from 1 to show that A inverse times A squared is equals to A. This is our A. So let's see if, so we are simply getting the product of the two. We have A inverse, which is this one. So we have A inverse A squared will be equal to negative 4, 7, negative 1, negative 1, 1, 0, 3, negative 5, 1, then times A squared, 3, 9, negative 2, then 12. Let us see. So we have negative 4 times 1, we have negative 4, then plus 7 times 2, 14, then negative 1 times 9 will be minus 9, like that. Then we have, move on, negative 4 times 1, we have negative 4, then plus 7 times 0, 0, then plus negative 1 times 2, we have 2, like that. Then we move on, negative 4 times 2, we have negative 8, then plus 7 times 3, 21, then negative 1 times 12, minus 12. We are through the first row. Negative 1 times 1, we have negative 1, then plus 1 times 2, 2, then plus 0 times 9, 0, like that. Negative 1 times 1, we have negative 1, then plus 1 times 0, 0, then plus 0 times negative 2, we have 0. Negative 1 times 2, negative 2, then plus 1 times 3, 3, then plus 0 times 12, 0. 3 times 1, we have 3, plus negative 5 times 2, so it will be minus 10 here, minus 10, then plus 1 times 9, have 9. Move on, 3 times 1, we have 3, plus negative 5 times 0, 0. Then negative 1 times negative 1, negative 2, have negative 2, have negative 2. Then lastly we have 3 times 2, 6. Then minus negative 5 times 3, 15. Then you have 1 times 12 plus 12, like that. So this negative 14, negative 4 plus minus 9, you get negative 13. Negative 13 plus 14, we have 1 here. Here we have negative 2, 8 minus 8. So negative 20 plus 21, we have 1 there. Then here we have 1 because we have here we have negative 1 plus 2, and then here we have negative 1, and then here we have positive 1, and then here we have this plus 12 minus 10, we have 2. Here we have 3 minus 2, we have 1. 6 plus 18 minus that, we have 3. Therefore, this equals to, we have 1, negative 2, 1, 1, negative 1, 1, 2, 1, then 3. So when you multiply A inverse times A squared, you get this. But with this equals to A, you can see it equals to A. Therefore, we have proved. Thank you for watching and listening.